America's working class has been cheated. That is an assertion.
Open border coordinate.
No, that's a Koch brothers proposal.
And the Democrats jumped right on board with the corporatists. They got in bed with Wall Street, military-industrial complex, the fossil fuels, Silicon Valley. And now look what happened to the country. We have the biggest income disparity since the Gilded Age. Bigger than that. There's more.
Expanded trade has thrown the working class into much more competition than they experienced before trade with lower wage countries took off.
Can say is that as a country, we have to make a different set of choices because the choices we've made have hurt working people.
Congressman, because I wouldn't know what to tell you to write. I don't know what to do about the depression and the inflation and the Russians and the crime in the street. All I know is that first, you've got to get mad. You've got to say, I'm a human being. God damn it. My life has value.
Hello, today is May 3rd, 2024, and welcome to the Institute for Sound Public Policy podcast. I am your host, Kevin Lynn. The topic of climate change and what it entails has taken on a life of its own in the global discourse, and in many respects has been propelled into something of cult status with armies of zealous believers and deniers. Today, I have asked two friends of the podcast to join me in examining the climate change narrative, the inner workings of the theory, its adherents and dissenters, and is it science or is it theology? I also wanted to delve into the actual science of climate change and its scientific underpinnings. So, first off, joining me will be KMO. KMO, welcome to the show.
Hey, Kevin. Good to see you.
Right on. And KMO was the host and producer of the long-running Sea Realm podcast. He continues podcasting with the KMO show and publishes frequently to his KM Optimal Substack, where he has covered a wide variety of topics in his 2 decades of podcasting and blogging. He studied the philosophy of mind and the philosophy of science in graduate school in the 1990s and has been commenting frequently on the country's political and cultural divides. He's also the author of a new science fiction novel that I'm going to share with everyone, and it is Fear and Loathing in the Kuiper Belt. And we're going to kind of go KMO to tell us more about that during the podcast. All right. So our next guest is Michael Axelrod. Let me go ahead and mute. And Michael, how you doing?
Okay, can you hear me?
I can hear you just fine. Great to have you here, Michael.
My picture had a microphone with a slash through it.
I know. I got it. I got you unmuted for the intro. Okay, so back at it. So I'll do your intro now, Michael. Right. Michael is our in-house science guy, and we can always turn to him to help us with science, technology, engineering, and math issues. He has an undergraduate degree in electrical engineering from RPI, that's Rensselaer Polytech Institute, and a graduate degree in applied mathematics from the Koonin Institute. His work experience exceeds 50 years and includes radar, signal processing, pharmaceutical research, survey design and analysis, statistical inference, mathematical modeling of physical and biological systems, time series analysis, radiation transport, and nuclear weapons. He spent 30 years at Lawrence Livermore National Laboratory working full-time, and another 10 years spent working part-time. He has consulted for the nuclear industry on reactor safety calculations. And as I'd mentioned earlier, both KMO and Michael, I count amongst them as my friends, and whose opinions I've come to appreciate and greatly respect. So without any further ado, gentlemen, let's jump right into the podcast. All righty. Great to have you both here.
Good to be here.
Right on. I'm going to do a quick sound adjustment. Michael, do you want to say something?
Okay, I notice a little bit of a visual latency. So if I raise my hand, it takes a few hundred milliseconds for it to
Okay.
occur.
I think
Yeah,
that's
probably
going.
normal.
That's on your end. On my end, it's looking pretty good. And KMO, you're
Okay.
looking good as well. So here we go. Well, gentlemen, I wanted to start off first, kind of getting your opinion of something, Michael. And you had turned me on to Koonin's book. Steve Koonin, he wrote a book called Unsettled. He's a scientist. He taught at Caltech, no small feat. And his, I guess the thesis of his book is that, this the science on climate change is far from settled, and he's something of a dissenter. And I wanted to get your opinion on this quote because I think it can set the trajectory of the podcast. Because he said, while modelers base their subgrid assumptions upon both fundamental physical laws and observations of weather phenomena, there is still considerable judgment involved. And since different modelers will make different assumptions, results can vary widely among models. This is not at all an unimportant detail, since ordinary fluctuations in the height and coverage of clouds can have as much of an impact on flows of sunlight and heat as do human influences. In fact, the greatest uncertainty in climate modeling stems from the treatment of clouds. So, what are your thoughts on that, Michael?
Well, I agree with him 100%. The cloud physics is the Achilles heel of the whole modeling enterprise. The general circulation models, which basically divide the atmosphere up into these three-dimensional cells. I forgot, it's something like 10 kilometers, or maybe it's 100. Doesn't matter. It's a big number compared to the size of a man. So these GCMs are solving transport equations, mass in, mass out, energy balance, momentum balance, these basic physics quantities. But this all occurs on a big scale. The cloud physics occurs on a small scale. So these GCMs with the wide resolution cells can't do the cloud physics. So they have to resort to various empirical approaches, crafting their own formulas. So that's why if you have 12 different modelers, they'll come up with 12 different results because each one is using different empirical models for the cloud physics. And this is one of the causes of the fact that something called the the equilibrium climate factor, and that's the change in temperature with a doubling of the CO2 level. That's usually reported in terms of a confidence interval, and they get something like 1.5 degrees centigrade to 4.5 degrees centigrade, and those endpoints differ a little bit in time. One important thing, I don't know if this is still true because I haven't checked lately, is that confidence interval has not shrunk since the 1970s, which shows you they haven't made much progress in reducing the uncertainties in the cloud physics and their effect on the results. So yeah, once again, cloud physics, Achilles heel of the whole global warming enterprise, because as Koonin points out in his book, a small change in the Earth's albedo, that's the reflected light, from 30% to maybe 5% more than that, can completely wipe out this predicted warming caused by a doubling of the CO2 concentration. So these things are highly sensitive to the model inputs. And to go further, this is nothing new in science. If you go back to early antiquity, to Ptolemy and his model of the universe. So they had fixed stars, and they supposedly were on a shell. You had moving points, planets. Planet means wanderer, and the ancients saw these things, these dots of light wandering around, and they called them planets. And then, of course, the sun wanders and the earth wanders. So they put the earth in the center of the universe, and everything went around the earth in perfect circles. Their idea that, God created the universe, God is perfect, he's going to use a perfect geometric figure. Well, one of the problems with Ptolemy's approach was Mars, for part of the year, started going in the wrong direction. Whoops. That's a problem.
So what is that? Mars retrograde?
Yeah. So Ptolemy fixed it. Now instead of having the planets and the sun going around the earth in a perfect circle, he visualized these points, these virtual points. They're in orbit around the earth, but the individual planets are in orbit around these individual points. He made other adjustments. Some of them you would think was severe. The actual center of it, he moved away from the earth like that, okay? And then there was a final phase 3 adjustment of the center of the whole shooting match, and they adjusted that too. So Ptolemy played around with his basic models. 1,500 or more than 1,500, 2,000 years ago. So then the more modern era came with Galileo, Copernicus, and Kepler. So they fixed it up to have the sun in the center with the planets orbiting in elliptical trajectories around the sun, which is more or less the correct model. But now here's the point, and here's what applies to current modeling. If you look at Ptolemy's configuration there and how well it predicted things, very well compared to the Copernican and Kepler system. In other words, the wrong model was getting close to the right results. That's kind of shocking. How could that be? Well, we now understand that better. Each one of those circles, right, those virtual things, as well as the period of the orbit, is an adjustable parameter. So when you think of the adjustable parameters as tuning knobs. So you have this data, you have this model, and you have these knobs that you can turn to get the data to match the model better. That's what Ptolemy did. It's what modern people do. It's what I saw in national laboratories. Now,
So is that tweaking the knobs?
What's that?
Now, is tweaking the knobs ethical?
Well, it depends how much you tweak. Depends how much justification you have. Let me put it this way. So 2 points determine a line, right? 3 points determine a circle. Suppose you have a bunch of points and it's not quite a line or it's not quite a circle. Let's say it's not quite a line. It fluctuates around a line. Well, you can fit, instead of a straight line, you can fit a curved line, a polynomial, and you can keep that going. If you have as many parameters as data points, you'll get a perfect fit. So there's obviously a stage at which you're overfitting. In other words, you're fitting noise. Okay, and this happens all the time in modeling in the modern era. And one of the ways of coping with this are this Japanese statistician Hirohito Akihiko. He invented this thing called the AIC, which basically tells you when to stop. Okay, so here we get into the honest part of where we're not going to overfit and report that. We're going to stop at a rational position. So I included it in the reference chart of basically it was scientists reveal the what's inside the black box. That's basically those tuning parameters.
Interesting. Wow. Cool.
Yeah.
Well,
And that's one of the things you can ask a modeler. If we had senators and whatnot that had any scientific knowledge, I would say, gentlemen, how many free parameters do you have in your model? And what do you do with them?
there you go. Interesting. Well, thanks so much for that, Michael. I thought what
Was
I would
that clear? Do you want me to go over any part of that? Did I talk too fast or too technical?
No, I think that was good.
Okay.
Thoughts, KMO?
Well, I read the book, The Copernican Revolution by Thomas Kuhn in grad school. And then he wrote another book where he elaborates on, on the shift from the Ptolemaic model to the Copernican model. And that book is very famous. It's called The Structure of Scientific Revolutions. I think people who are not interested in the philosophy of science, will have either heard of that book or maybe even read it at some point. So I can go into what Michael was talking about, I think, in unhelpful detail, and I will just pass on that opportunity.
But you agree with what I said, KMO?
Well, let me address Kevin's questions when he said, is it ethical to tweak the knobs? You have to. If your hypothesis does not fit observed reality, you have to adjust your hypothesis. You have to. I mean, there's not a question of ethical or not. The question is, how much tweaking can you do on your hypothesis before you really have to examine other models which are radically different from yours? And that's something that, this isn't Thomas Kuhn's quote, but it applies to Thomas Kuhn's model of the change of scientific paradigms. The quote is, funeral by funeral theory advances, which means that people with gravitas and academic degrees and prestigious positions in scientific and university structures, they become attached to their theories for very human reasons. And because they are influential and because they are powerful, they can shut down people who might have a different and better theory, or a better hypothesis, but they can't do it forever. Eventually they do retire, eventually they do die, and they make room for new ideas and, younger minds and different energy. And that, as Michael was saying, the Ptolemaic model, which had the sun in the center of the solar system, had been refined according to observations, very careful observations of the sky, for over 1,000 years. And it made some very precise predictions. And when Copernicus substituted, the change that Copernicus made was that he put the sun in the middle. But the idea that orbits would be circular was sacrosanct, and Copernicus didn't question that. So he put the sun in the middle of the model and had all the planets going around it in perfect circular orbits, and his model and his predictions were less accurate than the Ptolemaic model that had the Earth in the center of the solar system. Why was that? It's because planets don't have circular orbits. They have elliptical orbits. Mm-hmm. And it took a lot of observation and trying to fit the anomalous observations with the new heliocentric model before somebody came up with the idea of, hey, what if these orbits aren't perfectly circular? But the circle is a perfect shape, and it had captured the human imagination for thousands of years. And so dislodging the idea that things in the heavens are perfect and perfect things have perfect shapes, that was a psychological hurdle that Copernicus himself couldn't get over, even though he did make the right adjustment of putting the sun in the center.
Ptolemy himself sort of abandoned the perfect circle. It didn't really work. And so he had to change, and I have this in my notes, he had to make some fairly substantial changes. He had to move the center away from the earth. And that's, since it was so important to put the earth in the center, that's really a radical departure from your basic model. But again, I return. The reason he did so well is he had all these free parameters to adjust to match the data. Do you guys know what a French curve is? Have you heard of that?
I know what the handheld tool is.
It's an old tool that, in my day, being ancient, we used as undergraduates. You got a bunch of points and you want to put a smooth line through it, smooth curve through it. Graphically, you use something called a French curve. Today, you do that all with computers and spline fits and least squares, splines, all kinds of fancy things. But a lot of these things, complicated things, amount to a French curve. And even some of these sophisticated models that the national labs use, you've got the data you get out of the test and the predictions you get out of your codes, and they don't quite match, and so you have to come up with some excuse, energy flows and stuff like that, and tweak different things. I had a friend, and he told me in one of the major codes, he found a software error, not a physics error, but basic programming error, and he corrected it, and its bosses told him, put it back.
Well, there you go.
Because it was working to their satisfaction with the errors.
Well, it's interesting. That's a good segue. I want to share some quotes from the introduction of Koonin's book. Here we go. I think I have it up now. And this kind of explains that, it's not about the science. It's about special interests. It's about preserving and creating a narrative that works for certain people. For instance, couple of the quotes he has in the book. This one from Timothy Worth, president of the United Nations Foundation. We've got to ride this global warming issue. Even if the theory of global warming is wrong, we will be doing the right thing in terms of economic and environmental policy. And this one from Daniel Botkin, former chair of the environmental studies at University of California, Santa Barbara. Some colleagues who share some of my doubts argue that the only way to get our society to change is to frighten people with the possibility of a catastrophe. And therefore, it's all right and even necessary for scientists to exaggerate. They tell me that my belief in open and honest assessment is naive. So, gentlemen, there we go. People who are well embedded institutions that we should be able to rely on and trust are basically saying it's okay to tweak the knobs, when it serves another, what they feel is a greater purpose. Kind of that, there's an urban legend that sprouted out of the late 60s called the Report from Iron Mountain, where
I remember that.
Yeah, where a certain think tank said, gee, what do we do after the Cold War to keep everyone together, to keep the herd in place, kind of, and keep this, the bureaucracy running things, the people running things going. So kind of makes you think. So my thought was, I wanted to play a quick clip by Michael Crichton that, Michael, you had sent to me on his notion where he begins to bring in this notion that climate change is becoming more of a religion. And then I want to read a quote, KMO, from one of your recent blogs on climate change. So let me go ahead. I got to do a couple of things here before I do my app share. So we should have that open. I think you guys should be able to see the screen with Michael Crichton.
Mm-hmm.
Okay, great. I'm going to go ahead and play it, and please let me know if you can't hear it.
Benchstock, I'm also a freshman here. You stated in your remarks to the Commonwealth Club in San Francisco that one of the most powerful religions in the Western world is environmentalism. Can you explain why you refer to environmentalism as a religion?
Because I have training in anthropology, the idea that anthropologists have about what constitutes a religion or what functions a religion serves are a little bit different from how you think about it if you categorize religions as, Christian, Muslim, Hindu, something like that. So from the standpoint of an anthropological view, a religion is a collective set of beliefs. There is a leader or leaders who promote the beliefs among the followers. Followers make some kind of contribution or change in their lifestyle based on the religious belief. The religious belief gives them a total view of the world in terms of how the world is structured, what's right, what's wrong, what's good action, what's bad action. That all fits perfectly onto environmentalism. The other thing that environmentalism does, which I said to this group, is that it rather precisely maps a lot of Judeo-Christian beliefs about the origin of the world and so on, so that in environmental thinking, there is a view that there used to be a sort of Eden, and then people came and ruined that Eden, and that we are therefore sort of original sinners because we're destroying this planet. And what we can do, however, is get salvation through sustainability. And
there we go. All righty. And now I want to bring up KMO, your quote. And let me make sure I have. Right. Here we go. So this latest quote comes from a article that you wrote recently in a blog called Climate Doomers and Cultivated Fragility. And one of the lines in it was, he said, I also suspect that the person who is tormented by unrelenting climate change anxiety spends too much time indoors, doom scrolling. Concentrations of atmospheric carbon, as measured in parts per million, is so disconnected from the lived experience of any mammal that any emotionally crippling obsession with the topic is a symptom of a natural deficit disorder. That said, the climate doomers' holistic consciousness may have supplied them with the very correct intuition that they are confronted by something impersonal, unstoppable, and all-consuming. Their initial intuition was correct, but they went astray when they accepted someone else's ready-made articulation of that intuition. Wow, that was awesome, KMO.
Thank you.
So, I think now would be a good time to begin to delve into, when we look at climate change, is this something that's based on good hard science and is being pushed kind of from the scientific community up to us? Or is this something coming down from above and is taking on all the trappings of political institutions trying to push a narrative? What are your thoughts on that, gentlemen?
Well, I would say, in general, yes to all of that. There's this whole global warming, climate change, whatever you want to call it, business. It's a vast array of disciplines. I mean, it includes statistics, physics, chemistry, and all the subdivisions of those, like solving the Navier-Stokes equations, radiation transport. So you need a a team. You need a collection of teams, and you can go wrong in any one of the boxes. And there is a tendency in science and medicine too, especially, I call it the silo effect. You're in your little silo and you are very good at what you do, very up on everything, but you don't have the big picture. You don't know where other parts of the enterprise are going wrong. And so you can get to the point where you've got a collection of things. Each one of it is sort of almost correct, but the whole thing doesn't hang together. It's like building a house or a building, and you have the different subcontractors, and then you have the general contractor. I don't see much of a general contractor for the climate change. Somebody with a broad general viewpoint of the whole thing, who can make all the pieces play together. Koonin, I think, comes close to that because he spans physics, computer programming, statistics, etc. So I'd like to see a real general contractor get a hold of this business.
Interesting. Great. KMO, your thoughts?
Well, my project is not really to criticize climate science. I haven't read Koonin's book. That's just not my area of interest. What my area of interest is, social dynamics. And most people generally don't know anything about science. They have some strongly held opinions on scientific topics where those topics cross their political and cultural obsessions. But elsewhere, they have no interest. I went, for the recent eclipse, I went to a very lovely location where I spent several days in the company of some very lovely people. But they were mostly, strong blue tribe people, very committed to all of the blue commitments, feminism, and most importantly, in this instance, climate change. The person who invited me also had a physical copy of my novel with them. Again, my novel is Fear and Loathing in the Kuiper Belt. And several of the really passionate blue tribers who were very committed to the idea of climate change and being their side, their cultural tribe being on the side of science, they asked me how to pronounce Kuiper Belt, and I told them, and then they asked me what it was, and I started to describe it, and then a light came on, and they realized, oh, wait a second, he's talking about something that's real. Like there really is this thing in the solar system out past Neptune called the Kuiper Belt, and they had no clue. They didn't know that it existed, but they thought that their team was really on the side of science, and that they personally had a much better grounded worldview, scientifically speaking, than their cultural opponents over on Team Red. And so, so what? That's fine. It's a shibboleth. The idea that climate change is real and you have to accept it in order to be an acceptable person, to hold legitimate beliefs that an adult holds. This is just something that blue tribers say to identify one another to each other. So one of the people that I was talking to, one of the first things he said, like we'd never met, he didn't know anything about me, but I suppose because of my diction or whatever, he assumes that I'm in the blue tribe. And he just throws something out to sort of break the ice and establish, rapport. And it was just this really heinous, ugly stereotype of people that he calls followers of the orange Jesus. And this is a person who believes that his worldview is enlightened, that it is compassionate, that he has no room in his heart for hate, and that his viewpoints are grounded and validated by science. And these are some of the same people who will tell you that the current geological period is the Anthropocene, which it is not. The current period is the Quaternary period. What they mean is the current epoch, which is the Holocene, which is basically, we are currently in an ice age. The Earth spends about half its time in an ice age. We're in one right now, but we are in an interglacial period. And when the glaciers last retreated and we, entered into this most recent interglacial period in the current ongoing ice age, this most recent period is called the Holocene. And, if you the literal meaning of Holocene basically is recent, like the most recent. It's completely neutral. But there's a group of people who want to change that to the Anthropocene, which is to stress that it is human activity which is changing the climate. That's a very political message. But there is a scientific body which is responsible for making decisions about what the layers in the rock are called. It is a panel. I don't know the exact name of the organization, but it's a panel on stratigraphy, which is the science of the rocks. And repeatedly, this Anthropocene working group has brought the proposal to the major body to say, hey, we need to rename the current era or the current epoch. And the professionals in the field all get together and they look at it and they're like, no, your proposal doesn't have scientific merit. The fact that you ended it with scene to rhyme or to sound like Holocene, that's just pseudoscience. You're taking a political idea and you're dressing it up in scientific sounding language, presenting it to the scientists reject it, but then you go to the public who doesn't know anything about science, and so you say, no, we're actually living in the Anthropocene right now. And if you go and you search for academic papers about the Anthropocene, you'll find thousands of them, but they're all from critical studies and liberal arts majors, people who have no interest in science other than invoking science as an authoritative, as an authority, basically, to validate their point of view. So, liberal arts majors the world over believe that we're living in the Anthropocene, when in fact that is pseudo-scientific gibberish. And I'll stop. You can tell I'm irritated by this.
One question to ask the Blue Tribe. I'm making up a term.
No, you're not. It's a well-established meme.
What observation or experiment could we do that would refute the basic hypothesis that the Earth is suffering from human-caused global warming, and this will lead to catastrophic consequences? Well, this is a key feature of a scientific theory. What's the philosopher of science name where this comes from?
Thomas Koonin. This comes from this.
No, it's not
structure. Well, Kuhn talks about it. He says that, or is it Popper? One of them says that for a statement to be a scientific statement, it has to be falsifiable. There has to be some observation you could make which would falsify the theory. If it's not falsifiable, it's not a scientific statement.
Exactly. But I think that started with Popper, didn't it? You probably know better than me. I think Karl Popper, it was the first to enunciate that. Well, let me give you an example of a perfect application of that, and that is Albert Einstein, Special and General Theory of Relativity. So Einstein wrote his paper on the special theory of relativity while a full-term clerk in a Swiss patent office. 2005, that was a very good year for Einstein. If I'm remembering correctly, published 3 papers. Oh,
you mean 1905?
Yeah, what did I say?
2005.
Not as good a year for Einstein.
The 3 papers were Special Theory of Relativity, which the title of the paper was On the Electrodynamics of Moving Bodies. That's the special relativity paper. The other one was on a photoelectric effect. And the third one was the Brownian motion. I mean, that paper kind of convinced the scientific world that atoms were real and not just a convenient fiction for predicting things. So he had a very good year in 2005.
In 1905.
In 1905. In 1905, in 1960,
we're messing with you.
He came out with the general theory of relativity, which is far more complicated, requires non-Euclidean geometry, all kinds of things. And incidentally, that is one of the things it deals with is the perturbations or anomalies in the orbit of Mercury. Unexplained by Newtonian mechanics. So up to that point, Newtonian mechanics ruled the planets go around the sun in ellipses, but you have to modify that because the different planets affect each other. So you have to do what they call perturbation theory to get the actual orbit. But that all revolves around Newtonian mechanics. Einstein brought a whole new picture into it, and you get actually slightly different orbits. You can't do the GPS, the general positioning satellite stuff where we get our navigation from without the general relativity equations. The corrections are that small, and the consequences of small changes affect the accuracy. So yes, you have to use full-blown general relativity in designing those algorithms. So that was, a major step in scientific revolutions due to Einstein, and it's the last one, showing you once again science is not settled. So, okay, his final theory of general relativity. What's the test? Now we get to Popper. What's the test? And that is the deflection of light rays by the sun. Okay, so the concept of light ray itself, right, is an approximation, okay, because light is an electromagnetic wave, and you have diffraction, you have all kinds of things. Well, a good approximation, a limited approximation, is the ray approximation. That's what's used to design your eyeglasses and telescopes and things like that. So we'll stay in the light ray domain, and the gravity from the sun tugs on the light beam as it goes by and deflects it a little bit. And Einstein calculated that and got half of the right answer initially. Okay. Anytime you want a little culture remark, anytime you want to scare a physicist, okay, you look at his work and you say, I think you might be off by a factor of 2. You'll probably send him into a panic because it's such an easy mistake to make. Almost everybody does. But anyway, so Einstein then says, there's another term. And that is due to the distortion of space itself, whatever that means, by the presence of a mass. And so you get more or less general the deflection than Newtonian mechanics would predict. And so now does that occur? So now we have the definitive experiment. You look for an eclipse of the sun, and I think they went to 2 or 3 of them, and some of the data got screwed up. It didn't finally get completely resolved until the teams at Lick Observatory, which was near where I lived in Livermore, California. It's up on top of Mount Hamilton, beautiful space. They did the final reductions of the data, and sure enough, Einstein's calculations were correct. Within an experimental and measurement era, they matched the predictions of the theory. So that was the point. If the actual ray from the sun had not been deflected by that much, Einstein's theory would have been dead. So there's a perfect example of a testable hypothesis. We don't have anything like that for global warming. The whole thing is too complicated, too multidimensional, too nonlinear to have it come down to a single test. Oh, okay. I'm going to want to come back to Einstein, and this is connected to global warming. In 1931, a book appeared in German, and it's just been available in English on Amazon, I think in 2021, not 1921, 2021 or 22. And it's, I'm paraphrasing slightly, 100 scientists dispute Einstein. And these were 100 or 101, something like that, legitimate, recognized science, not all of them, but most of them, professors and stuff like that. They published this book. Each chapter was a critique of Einstein. And a reporter asked Einstein, well, what do you think about these 100 scientists disagreeing with you? And his response was, if I'm wrong, it only takes one. And you hear this when you go, and these are fallacious anyway, 97% of scientists agree. Well, first of all, that's completely false. And I have a reference to that. That study, it was fraudulent. Okay?
And in fact, Koonin talks about that in the book. You know, it was a subset of all these thousands of scientists that they surveyed, right?
Oh, and they were misrepresented. Yeah, I mean, they had scientists included, like Nir Sharav. He says this on his website. They had him as endorsing it, and he's a critic. Yeah, it's completely untrue, and I like the Einstein quote because it kind of shows you science is not a democracy. I don't care how many people you get, what kind of a mob you get. What counts is the logic and the experiments and the data and all that stuff is the final word, whether or not everybody else disagrees with you.
Right.
I'd like to touch on that.
Go for it, KMO.
In most of science, this was true in the past, and it's still true in most every area of science other than climate change. Your goal as an aspiring, like upcoming young scientist is to prove some old established scientist wrong.
Right.
You know, if you can knock somebody off their pedestal, then that's your ticket to fame. That's your ticket to a career advancement and a secure job in a university someplace where, you know, you don't have to teach much and you don't have to publish much. You're on the gravy train. You're set. Climate change is different, because it's not just science, but it's science plus government policy, plus corporate interests, plus this huge cultural like agglomeration, which has attached itself to the science of climate change. So climate change is very different. If you are an upcoming climate scientist, you absolutely will not question any fundamental, you know, tenets of the notion that human industrial activity is not only warming the planet, but warming it drastically such that it will be a threat to, you know, to the continuance of our civilization. So science doesn't work like science when it's climate science in the here and now.
Exactly.
Yeah.
And that applies to Einstein.
Yeah.
Einstein dethroned Newton.
Yeah, I think oftentimes, so now everyone would rather demur, you know, when it comes to stating something that might be, whether it's climate change or something that goes against the perceived values and narrative of their tribe. They won't challenge things the way they used to. And, you know, what you had said earlier, KMO, had me thinking of two books I'd read in the past. One was Jane Jacobs' The Coming Dark Age. It was the last book she had written before she passed away. And she spent a whole chapter on education and specifically credentialization. You know, this push to get people through college and get them a credential. And interestingly enough, college for the masses in America is a post-World War II phenomena. Prior to that, if you went to college, you either had the means or you were exceptionally smart. And I'll give you a personal example. You know, my father was a flight engineer for Trans World Airlines, flew with them for 30 years. He was flying a 747 before he retired with a high school education. And it was his older brother, the nuns thought, would make it out of the coal mines into college, because it was that unattainable. You had to be that gifted. And I wonder if we put too many people through college that shouldn't be there. They're not capable of the critical thinking that kind of credential used to be indicative of, one way or another. I'm reminded also of, you know, with Curtis White, a social critic. He had written a book called The Middle Mind, and he didn't describe it so much as, you know, middle brow, but it's where Madonna and Mozart have the same value, where you know, you're pining about the loss of wilderness and the Arctic preserve while you're driving your SUV. There are just some things that just defy critical thinking. And unfortunately, I think we have this generation of midwits that actually think they're pretty darn smart, and they really aren't. So
I can elaborate on that a little bit. There's two things that really pumped up college attendance. First one was the Vietnam War. You could get a student deferment by being in college. And the second one is less known, and that is a Supreme Court decision called Griggs versus Duke Power. That's Griggs with a G, like George, Griggs. And what this Supreme Court decision essentially did away with was any kind of testing, aptitude testing for admission to a company or for advancement in the company. And it used to be companies would offer the more intelligent members of their staff the opportunity to take courses to advance within the company. You know, like E.I. Coca started off in the mailroom and eventually became CEO. This Supreme Court decision did away with that. So companies began using the university system as their front-end filter for hiring, because they could no longer take the shortcut and use any kind of testing, especially IQ testing. You know, IQ is one of the most predictive parameters of success. And, you know, we can even barely say IQ anymore. It's become such a taboo subject. But the one exception to that is the military can still use something called the AFOQT, the Air Force Officer Qualifying Test. I took that as an undergraduate in ROTC, and because if you want to train pilots, it's very expensive to train a pilot. So you can't just take people at random, because a lot of them are going to flunk out. So to make it economically possible to do that, you have to do testing. So the military gets a pass on that, but companies don't. And so that's one of the driving forces for increasing college admissions from, I think when I applied to college, it was something like 5 or 10%. And now I think it's close to 50%. If somebody knows a better figure, tell me.
Interesting. Anything else you think we should add to the conversation?
Just a personal statement of my own, which is that I am not a detractor of science in the least. I value science highly, and I do believe that over the long term, science is self-correcting, but it doesn't take place in a vacuum. It takes place in a human society done by humans. You know, they have social pressures upon them. There are commercial pressures. There are governmental pressures. There are academic pressures. So for a time, in certain areas, science can get really twisted up, and you can have a lot of just reprehensible behavior taking place in that arena. But it is my conviction that over time, science is self-correcting, and it does get us closer to a useful and accurate understanding of how the universe works.
Well, with me personally, more than an interest, but a career, which started at about 7 to 7.5 years old. I lived on the west side of Manhattan as a young boy, about 15 blocks north of the Hayden Planetarium and the Museum of Natural History, which in those days was attached to it. And so I think my father brought me to the planetarium at about 7.5, and then when I was 8 and 9, etc., I would go on my own. It was a short walk. And those lectures were fabulous. We actually had a real astronomer in the dome, auditorium with the Zeiss projector giving us lectures. And that's where I first learned, the heliocentric theory, right, and the structure of the universe, and what causes the seasons. And I knew at about 8 or so what I wanted to do with my life, and I went and did it exactly what I thought at that age. I laid out a path and followed it, and had a full career. And so, with me, it's something very special. It's been my life, and I'm really disturbed by the corruption and the politicization of science that we see. This is Lysenkoism expanded. In fact, I would say we are in worse condition now in the science enterprise than the Soviet Union was, because the corruption and politicization now extends. The scope is much wider. There's hardly an era that's not affected by this. Let's take one thing that's very neutral, okay? Mathematics. Now mathematics has become politicized. State of California has a curriculum that essentially calls mathematics racist. That getting the right answer, showing your work, is a racist thing. This is, in fact, worse than Stalinism. Stalin at least left the mathematicians alone. He didn't corrupt that part. So, I mean, think of how serious this is. Worse than Stalin, right? Mm-hmm. And I think that I'm not the first one to say that, or the last. We are in a very serious situation now, and I don't have the optimism that KMO does. We could fall into, a hole that'll take 1,000 years to climb out of if we're not careful, because the state, using technology, is now able to monitor us at the micro level and create a dictatorship that the likes of which we've never seen before.
Interesting.
I do agree with that danger. The Google knows so much more about you than the Stasi knew about any given East German citizen before the Berlin Wall came down. So far, they just want to sell us products, but more and more, and you see this particularly when you talk to the large language models, they're getting into thought policing and speech policing at a very minute level, on a very personal, intrusive level. And I think if we're not careful, and if that isn't remedied very quickly, that will be sort of written into the DNA of much more powerful, complex, and far-reaching AI systems. So that is a definite danger. I do agree that a technologically enabled, very politicized, sort of Stalinist or Maoist themed government could be a real, they could just bring on a hell on earth for all of us.
And it's worse in Canada, and it's worse in Britain.
Yeah.
And it's really bad in Scotland and Ireland. Ireland has just come up with some kind of hate speech law, which is unbelievable. And it's turning one person against another, where you can turn someone into the police for making a statement which someone may find offensive. This is potentially the end of Western civilization unless we're careful.
Well, gentlemen, I'm hoping 10 years from now, all those people that wanted this government control, they bought off on these insane narratives, they're completely disavowed of them, and they would never admit to having carried the water for these things. But like you said, Michael, there's that old adage, modern technology creates modern monsters. And we don't know how far-reaching this dark age could be. We might be just in the beginning of it. They might just be getting rolling. So certainly things for us to be worried.
It's already reached a frightening proportion. If we're going to have digital currency, then whoever controls that can shut you down. You won't be able to buy anything, or you won't be able to buy food. Already, people, you have banks debanking people based on their opinions.
Well, they might feel that you consumed too much meat this week, and
right.
You don't get to buy anymore.
Or you drove too much. Or we're tracking your carbon footprint. And if you exceed this level, we're going to shut down all your accounts. Now, I had the IRS make a mistake. It was their fault, okay? and they shut off all my accounts. I had to get my daughter to pay my rent and use credit cards. And it took 11 months to correct that. And, they corrected it. They gave me back the money they took with interest and all that sort of stuff. But I got a taste of what it's like, what the government can do to you when it's their fault, and how difficult it is. It didn't take one phone call to correct it, and I had a CPA on it and whatnot. I was just getting ready to. Julie knew a lawyer, a tax law lawyer, was just getting ready to sue the IRS, and then I didn't have to. They came through. But you just amplify that by a factor of 100, and this is where we're headed if we do digital currency, which apparently is coming.
Yeah. So before we sign off, KMO, how can people find you on Substack and YouTube and all the other places?
Well, if you just Google KMO Substack, you'll find me. My novel is called Fear and Loathing in the Kuiper Belt, Gen X Science Fiction. And I have registered the domain genxsci-fi.party, which redirects to my Substack. But my Substack, it's kmoptimal.substack.com, but the title of the blog is Gen X Science Fiction and Futurism. So I do talk a lot about scientific topics, but also science fiction, which I am a lifelong lover and consumer of that medium, and now a producer of it.
Right on. Cool. Michael, how can people find you? Are you doing anything public facing these days?
Not really. Not yet. Our readers, I guess, listeners, viewers, I guess that's the right word, should look at the set of references if they want to go further. All but one of the references don't require much math. One on climate modeling requires a little knowledge of calculus, but the other ones, the Koonin book is a very good place to start. I think
really
it's well
is.
written. Yeah, I think he's a heavy hitter in his own right. He's got great credentials. He's got great experience. He covers the subject pretty thoroughly. He covers the defects in it. I would start with that, and then you can go to some of the references, some of the web pages which I listed to, like what's up with that, to get data and commentary on things like, are we having more and more intense hurricanes lately? That's another, and Koonin goes into that too. Okay, the point is, there's so much distorted and just plain lying stuff out there, and if you take away anything from this podcast, it is avoid the mainstream media. Do not rely on the mainstream media for anything about climate change, or in fact, anything else.
Yeah, there you go. NPR, BBC, ABC, MSNBC, CNN, Fox. Avoid them.
Yes.
There's so many great choices now on alternative media. You can find people you've been able to follow and trust, like KMO. And so, well, gentlemen, before we head out, let me just say to our audience, if you stayed with us this long, thank you. You are intrepid, to say the least. If you haven't, be sure to hit that subscribe button, because that's how you'll be notified of future podcasts. And if you're watching this on YouTube, hit that thumbs up. If you're following us on Twitter, or you're watching this on Twitter, hit that like button and be sure to follow us there, and Rumble as well. Great, gentlemen. Again, thanks so much for joining me today, and everyone have a great day.
Take care.